Okay, so my topic was understanding buffers and the Henderson-Hasselbalch equation. I believe that's topic 15. So to begin with, what is a buffer? A buffer is a solution that resists changes in pH when small amounts of acid or bases are added. So they are made up of a weak acid or its base, or a weak base and its corresponding acid. So for example, acetic acid, which is CH3COOH, is an example, or actate, which is CH3COO negative. So how do buffers resist pH changes? So if you add an acid, the conjugate base will neutralize it, and then if you add the base, the weak acid will donate a proton to neutralize it. So together, this prevents large changes in the pH, which equals the buffer effect. So what happens when acid and bases are added? So if there's more base than acid, then the pH will be slightly basic. And then the other way around, if there's more acid than base, then the pH will be slightly acidic. So this brings us to our Henderson-Hasselbalch equation, which is pH equals pKa plus the log of A neg divided by HA. So pKa is the negative log of Ka, so it's the acid dissociation constant, and A negative is the concentration of the conjugate base, and the HA is the concentration of the weak acid. So you would just plug in all of your numbers to get the pH of something that you're trying to calculate. And basically what helped me understand this is that if A equals HA, then the log of 1 equals 0. So then, the pH equals pKa. And if the base is larger than the acid, then the pH will be larger than pKa. And if the acid is larger than the base, then the other way around, pH will be smaller than pKa. So just like a lot of practice really helped me solidify when to use Ka versus pKa, and as well as always checking your units, which is mole divided by L. So to conclude, buffers resist the pH changes with weak acids and its corresponding base, and the other way around. They work by neutralizing added H or O neg ions. Also, the use of the Henderson-Hasselbalch equation helps find buffer pH using that ratio and the pKa. So thank you for watching. I'm excited to read everybody's responses to this, and I hope you have a great day.